All right, hello everyone. We're going to go over 6.2 and 6.4. There's a lot to cover because um, there's about 2 days worth for 6.2 and 6.4 each. Okay, and so we're going to start looking at different shapes and all the properties that come with them. Okay, so you know um, what knowledge you have about shapes that you learned in elementary and middle school. We are going to expand on that a lot. All right, so the first thing we're going to look at is parallelograms. All right, parallelogram is a quadrilateral four-sided figure whose opposite sides are parallel. Okay, and these are the five properties of parallelograms that you need to know. Okay, you need to be familiar with these. Study these. Okay, opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, meaning they add to 180, and the diagonals bisect each other. Okay. Um, so these are some examples. Okay, I skipped numbers 1 and 2 because I think they were a little bit easier. But like here, number 3, these are consecutive angles, right? Because if you were to expand and extend these lines, these line segments, right? Then these are parallel lines, and this is a transversal, right? And so these are same side interior angles or consecutive angles, and that's supplementary. So when you add it, it equals to 180. Okay. Opposite angles are congruent and measures are equal, so we set them equal to each other here. Sides, opposite sides are congruent, so again, setting them equal to each other. And then here, in number 6, it looks like, what did we do? 2x plus 4, oh, so the triangle, 2x plus 14, right, that's alternate interiors, and so these are congruent, and so these three angles added up make a triangle, so that equals 180, right? And kind of word problems, I guess. Okay. Um, if you need to, I believe 11 and 12 were blank, and it helps if you draw in a parallelogram. Okay. Notice A, B, C, D, you always go in order around. Okay. Um, Generally, we go clockwise. Okay. But as long as you keep the order. Okay. So AB is 3x plus 11, and etc., etc. All right. And so it looks like we set up, because we have opposite sides are congruent, okay, we set them equal to each other. Okay, so this little symbol, this little parallelogram, okay, that's how you know it's talking about parallelograms. Number 12, the perimeter is 96. Okay, if you add up all the sides, BC is 6 centimeters less than twice AB. So you have to label AB as x, and then BC is going to be 2x minus 6. I believe this is going into day 2, and so this is just a summary, okay, of the properties of parallelograms, all right, and just doing some more problems here, okay. Make sure you look over these notes. Try some of these on the blank set of notes that I sent you in the folder, okay. Um, if this is 110 and you know it's a parallelogram because the opposite sides are parallel, right? Remember, these arrows indicate parallel, okay? And so therefore the properties of parallelograms apply, right? If this is 110, then angle 1 is a consecutive angle, right? And so it's supplementary, so that means this has got to be 70, right? If and then angles 1 and 3 are congruent, opposite angles, and 2 has got to be 110 because they're opposite angles, congruent, all right? Okay. For this one, so we incorporated all this work here is part of number 1, actually, okay, where I'm highlighting and circling. we incorporated 8.5 using the law of sines, right? And so I think first we figured out, well, if this is 94 here, then angle W has got to be 94, okay? And then Z, and then if this is 26, then this is 26, all right? X is 13 because this diagonal is 13, or this half of it, right? Remember, diagonals of a parallelogram bisect each other, so if this is 13, then X is 13. And for Y, it looks like using 13 and 94, we use the law of sines, right? Because this side is 10, this right side has got to be 10. And so sine of Y over 10 is equal to sine of 94 over 13. So incorporating the law of sines here, okay? And oh, this one, I think there's a typo here, okay? Because it asks for angle D, and so this work is correct, angle A, using the trig ratios, right? Angle A, you have opposite and hypotenuse, right? Remember SOHCAHTOA, okay? You have to do the inverse because you're solving for an angle measure. But it asks for angle D, right? Angle D is consecutive with angle A, and so it has to be supplementary. So if anything, I think angle D has to be 180 minus this, okay? And so I just wanted to point that out. And then going to 6.4, day one. We're looking at rectangles first, right? And here, rectangles have all the properties of parallelograms plus 2 more because a rectangle is a parallelogram, right? A rectangle is a specific type of parallelogram. And so therefore, it's going to have all of the properties of parallelograms. And then additionally, 2 more that you have to know. That's why this is labeled 6 and 7. 4 right angles in the corners, okay? And then the diagonals are congruent. So AC is congruent to BD. If they are congruent, then they bisect each other, which again is one of the 5 properties we know. All right. And so, you know, using some algebra skills here, okay, we're going to incorporate a lot of algebra work, mixing it in with these shapes and these concepts, okay. Here you have to multiply 2x plus 7 by 2 because 2x plus 7 is only halfway, right? And so you need the other half, and it equals the other diagonal, x squared minus 8. And so we wanted to go over this as a review for quadratic formula, okay? All right, you can, I think it's in the past notes, or you can Google it, okay? But remember, quadratic formula is only when it doesn't factor, and then A is the first coefficient, B is the middle coefficient, and C is the constant, okay? And so please be careful of inputting these numbers correctly, okay, and then simplifying these radicals, all right? Okay, next up we have rhombus. Okay, again, a rhombus is a specific type of parallelogram, meaning the sides, the opposite sides are parallel. You have all of the properties, okay, and then plus 3 more, all right? All 4 sides are congruent, just like a square, okay? The diagonals are perpendicular, right? And the diagonals bisect the angles, okay? It doesn't necessarily bisect each other, okay? It might, sometimes, but not all the time, so that's why you can't put that property in there. But the diagonals bisect the angles every time, okay? And so we have this example here. If the perimeter is given to you, right, notice 8 root 5. So if you divide that by 4, that's how we got 2 root 5 for each of these sides, because 8 divided by 4 is 2, okay? And then one diagonal has a length of 4 root 2. Find the length of the other diagonal. Okay, so If it's 4 root 2, then each of these segments must be 2 root 2, cutting it in half. Okay. And then I think here we looked at maybe this triangle or this triangle, doesn't really matter. We use Pythagorean theorem, right? X squared plus 2 root 2 squared equals 2 root 5 squared. And notice, I want to point out, you have these parentheses here, okay, included with the squares, all right. Just another rhombus problem here, incorporating trigonometry, these trig ratios, right? You have opposite over adjacent, so you have to use tangent, okay? And then lastly, squares, okay? Squares have all 10 properties, all right? Square is a parallelogram, it's a rectangle, and it's a rhombus, okay? And so all of these properties are in a square, okay? All right, so again, this is one of those things, right? What the basic knowledge that you had about shapes from like elementary and middle school, and now in geometry class, you're going much, much deeper, okay? And so you're gonna use that knowledge here again. If you can see what I'm highlighting, this right triangle here, we know it's a right triangle because just like a rectangle, the corners have 90 degrees, okay? And so you got to be able to remember how to FOIL and double distribute. Again, it's a quadratic, so you probably want to bring everything over. If you're confused about this line where I'm highlighting to the next line, right, we divided everything by 4 because they were divisible by 4. And then we use the quadratic formula here. In this problem, if AF is 6, then what's the perimeter of this shape? Okay, I believe it's a square. You know it ends up being a square because of it's a 45, 45, 90 here. Okay, and so I think that was given to you in the problem. All right. And then, this is in the blank version, I believe. Okay. You were just given the diagrams, all right? And so you were asked, based on like what you can conclude, right? What's the most precise shape that you can name? Okay. For a square, all right, from a diagonal, angle 1 and 2, all right, the diagonals get cut in half, just like a rhombus, right? The angles are bisected. And so for a square, the corners get bisected to 45 degrees. Okay, so take a look at these problems here. Okay, and then this one again, some factoring problems. Okay, this is a system of equations, right? Taking one expression and substituting it into another expression. Okay. Right. Make sure when you do these problems, right, that you substitute these answers back in because it might not work. Like for this one, number 12, there are no solutions. I mean, algebraically, you get answers of 4 and 2, but when you plug it back in, they don't make sense. Okay, so make sure you do that. All right, here in 13, we connected sides and angles here. Okay, 2x plus 6y equals 90 degrees. All right. And I believe that's it. Okay. As always, if you have questions, please let me know. I will be sending out, I think, a review sheet. You'll have a little bit of homework also to complete, and get ready for the quiz tomorrow.